Okay, so we're going to talk about DevOps on cloud. We're going to talk about what we can do with cloud, how it can align with DevOps very well. Essentially, our agenda today is looking at what developing, what SysOps, and what DevOps is, and how do we define them, where we can draw the line between those concepts, and how DevOps combines the two methodologies together. We're going to look at CI/CD. We're going to look at CI/CD because it's a common practice for building software within DevOps. It does not need to be the methodology that you use. DevOps is flexible and you can use it, but it is really common because the goals of CI/CD and the goals of DevOps align very well. So they're both about agility, they're both about fast development, multiple iterations, testing, etc. Right? So the alignment is such that we usually just sort of automatically think about CI/CD when we talk about DevOps, even though those two terms don't really relate that tightly. They are two different things. We're going to look at infrastructure as code, which is definitely one of the advantages that we have when talking about cloud and CI/CD and DevOps processes. And then we're going to look at what the challenges, drawbacks, and benefits of DevOps are. So we're going to take a look at what we can do, what we can solve with DevOps, and what kind of drawbacks DevOps can have. We're going to look at the AWS environment with developer and DevOps tools. We're going to see what we can use in AWS, as this is sort of a presentation focused a little bit on AWS and our spectrum of trainings for AWS. And then we have a little Q&A session at the end, so that if you have any questions that have not been answered while the presentation was going on, we still have a little bit of time to take that and check it out. So essentially, we're going to look at development first. So what is development? Essentially, it's writing code, right? So when you write code, you're going to have 1, 2, 10, 100, 1,000 developers writing code. How do you create an environment where everybody can collaborate on that code, right? So usually what they're going to do is they're going to commit the code to a repository. That repository will make sure that everybody's changes can be tracked. Every version of the software iteration that we're doing can be tracked. And of course, the repository is a basis for automating your deployments when you're doing developing. On top of the written code, we're going to have to do testing. We're going to have two types of testing. We're going to have functional and integration testing. So functional testing is essentially making sure that the code that has been written is actually functional. It is operating. It's not throwing errors, etc. Right? So in functional testing, it's things like sanity checks. It's things like static code analysis. It's things like just deploying an environment with that new code, inserted into it, and seeing whether that new code works. And then the second step is integration testing, where we try that code against actual other components, an actual working environment, maybe mocking servers, etc. Once the code is tested, the next step is creating artifacts and packages. So artifacts can be sort of reusable pieces of code that can be put into different other processes. So we have two types of code that are being written. And so artifacts are sort of general code that can be used as part of multiple components, like, for instance, our authentication mechanisms for our microservices. Instead of writing an authentication mechanism for each microservice separately, we just write an artifact that does the authentication, and then we just plug in that artifact into each of our microservices with just a reference to where that artifact is sitting in the repository. And then we build packages. Well, packages will be installable pieces of software. Packages will be containers. Packages will be any kind of units that can be taken onto an environment and provide a running piece of software. Development sometimes also means installing and updating software. It's not necessarily part of it. That's why I've got a star right there at the end. So essentially, this is sort of a blurry line. Usually, it either stops before the installing and updating, or the developers also do the install and updating and then draw the line after that. So the application ownership in development is limited to the development cycle. It's limited to those features, usually creating the code, testing the code, and creating the packages, and then posting it somewhere and saying, here you go, you can install that software, or coming into an environment and installing that software and then saying, hands off, this is it, this is all you get, right? So what are we looking for when we're looking for development team members, right? First, they have to have good technical skills, not just the ability to write code, but have a solid understanding of IT concepts, have an understanding of what client-server methodologies are, what microservices are, how these components communicate over the network, which tells us that they have to have a pretty wide understanding, basic but wide understanding of the whole of IT, what CPUs are, what operating systems are, how code is run on an operating system or on a serverless environment, essentially, or in the cloud. Of course, their main value will be the ability to write the code, to write the scripts, to write things like automation, to write integration testing, to do the testing, etc. Right? So it's all about the code, but they do have to have a solid understanding of IT concepts. They also need to have teamwork skills, because developers will usually be working in a team, will be collaborating on the same piece of code, and we can't have people without teamwork skills working in such environment. That's just not something that we can have. So if we have such individuals in our development team, then we have to work on them much more to get them in line with the team, to get them cooperating. Whereas somebody with good teamwork skills that comes into the team will essentially integrate very easily. And of course, usually we're also looking at the ability to self-manage, right? The ability to sort of pick a leader amongst their peers, and to have the ability to know what types of reporting they need to do to that leader, and how that leader needs to aggregate reporting up to other levels of management, if C-level if necessary. So good communication skills are also a factor. Not all team members need to have good communication skills, but if we are looking for developers that are going to be in DevOps, they're going to have good communication skills, because it's a crucial part of DevOps to communicate what is happening, what the state of the application is, what we need to do. Don't be afraid to throw out ideas, recommendations, criticism, etc. Right? So DevOps is about making sure that we communicate a lot. So what is SYSOPS, on the other hand? So SYSOPS essentially is deploying and maintaining operating system and managing the infrastructure, making sure that those components work, making sure that those components are up and operating, and making sure that we don't have any issues disrupting that operational environment, right? So that also means things like securing the infrastructure, securing the operating system, and of course monitoring the whole environment. Right, so monitoring the infrastructure, monitoring all the middleware that's in the operating system, monitoring the operating system, and monitoring application specifics. So what they need to do is they need to understand, again, a wide variety of IT knowledge, wide technical skills. They also need to sort of understand what the application is doing. So they have to have some idea about applications. When they are managing the operating system, when they are managing these applications, a little bit of scripting also helps, right? So what are we seeing here? We're seeing some parallels being drawn with the developers, right? So SysOps people, they sort of have to have the same core knowledge of our environment as the developers. Maybe they're not as good at writing code, but they're better at making architectural decisions or identifying a problem when it's sitting there. One of the things SysOps is usually responsible for, but not always, is again installing and updating software. So that's the blurred line between SysOps and development, right? So if we merge those two together into DevOps, that's going to be the core requirement. And of course, usually in SysOps, application ownership is going to be limited to production phase, whatever the production phase entails. Like, for instance, it could be also staging plus production. It could be just the production after it's been installed and just running it. It could also mean decommissioning, so anything like that, right? So now we have essentially two teams, each taking care of and each having ownership of an application for about half of its time, right? So team development owns the application up until production, and then SysOps owns the application from production onwards down to the commissioning. So why not join these two together, right? So our SysOps team members, again, they need good technical skills. They need a solid understanding of IT concepts, right? So again, same capabilities as developers. They need to have the ability to manage environments, right? So managing environments, it's not about building software and delivering code. It's about having the ability to understand what's going on, having the ability to monitor the environment, having the ability to diagnose and quickly resolve issues that are coming up with the environment. If there's a spike in the CPU, how do we analyze where that spike in the CPU is coming from? If the disk suddenly has a full queue and the application is operating slowly, what do we do? What's responsible for that disk acting slowly? Is it a lack of space on the disk, lack of swap space? Is it a hardware issue on the back end, etc., right? So this is the kind of stuff that team SysOps needs to manage. As I already said, the ability to write some automation scripts is, of course, a great benefit in SysOps team members. If they know how to write a little bit of automation in JSON or a little bit of automation in YAML, that is a really big benefit. And that's something that SysOps team members, I would say, have to know. They have to be able to do that in a modern environment. Teamwork skills and the ability to self-manage. Again, same characteristic as with the developers, and of course, good communication skills so that they can clearly communicate what the current status is of the environment, what the problem is, where the problem is stemming from, how they came to the conclusion that that is causing the issue, etc., right? So sometimes you'll have a team member who's going to be able to fix everything, but when you ask them, so what went wrong, they're going to be unable to communicate that, right? So how do you prepare for the next time this issue occurs? How do you prepare for when this person leaves your company and they're somewhere else and they're unreachable and you have this problem and you don't know how it was solved? So good communication skills, the ability to describe what actions were taken, what the problem was, is sort of crucial when we talk about SysOps team members. In modern applications, these environments can be very complex. They can be built from physical servers, virtual servers, containers, functions that run somewhere on the cloud. They can have mixed tiers of storage, anything from block storage directly attached to machines and containers, to object storage sitting on a service like S3, to file systems that are distributed across environments, to external file systems that are visible on the NAS network, SAN boxes connected to the physical servers, etc., right? So when we're talking about these complex environments, a good SysOps team member will need to understand a huge wide variety of different IT concepts, and they will need to sort of be able to either escalate to the right person or even understand why this failure has occurred, why this issue is occurring, what this monitoring characteristic means. They have to be a jack of all trade and a master of all trades at the same time, right? Not a jack of all trade and master of none. They need to both know it and master it, right? So that's sort of crucial. So why DevOps? So essentially, DevOps is development and SysOps combined. Probably everybody knows that. The skills and the tasks overlap, as we've already said, sort of the installation, The deployment is sort of a blurred line where the development and SysOps merge together. And of course, with DevOps, what we get is we get complete application lifecycle ownership, right? That is the crucial sort of focus of DevOps, right? We put it in the middle of your screen for a reason. This is what you should be focusing on. This is why you should be implementing DevOps, right? So the tragedy of commons tell us that if something is common and nobody has ownership of it, it will usually be left behind. It will be mistreated. It will be abused and will not progress well, right? With DevOps, what we do, we say, here's a group of SysOps people, here's a group of developers, sit them down, tell them this is your application, you guys own it, you build it, you run it, and you decommission it, right? And it has to be the best application that was ever built by our company. Make it a competition, make it interesting, make it fun, and of course, focus on the teamwork, focus on the communication, focus on the team's ability to self-organize, right? Give them the freedom to self-organize. Tell them, here's 10 people, you guys are working together, you're building this application, and you need to build the best application that we've ever built. If you build the best application that we ever built, it's going to be a gold master for all of our applications. All your names are going to be credited down there. You're going to be famous inside of our corporation, or maybe even outside, or, you know, it's sort of something that should be rewarding in itself, is what DevOps is. So the DevOps cycle essentially is about having the ability to integrate all the different phases into sort of a circular fashion, right? So the first thing what you do is you plan that piece of software, right? You take your business idea, you take your business requirements, you take your client requirements, you take your backlog, wherever you're pulling ideas from, and you plan those ideas into an application, right? You create the feature list that needs to be developed, and then you start the development. Here's where the coding comes in. Here's where the developers should start typing, right? The planning phase sort of is focused on both the SysOps and the DevOps developers, and they need to communicate. So, okay, we're building this on microservices, we're building this on virtual servers, where we need a physical server for this, and why, right? And both teams have to say, yes, this is doable, this is the best idea. In the development phase, it's more about the people writing the scripts. The development phases can be very short, and we try to make them very short in a DevOps environment because we want to get code onto the test environment, onto the release cycle, onto the deployment fast, so that we can see whether it works. We want to deliver fast because we want to get very good time to market. We want to get a lot of testing done so that we can have a solid, reliable product that will work anywhere in any environment. And of course, we want to get some code delivered into the environment so that the SysOps and the monitoring tools and everybody who's working on that, QA teams, etc., can give us the feedback and say, yeah, this is exactly what we were looking for in planning, or they can say, what were you guys thinking? This is not even close to what we were trying to develop. So the testing phase is sort of the crucial part where you verify that whatever was developed works, and you verify that it does meet the objectives of the client. A lot of the times, that second part is forgotten about. Meeting the objectives of the clients is sort of the most important thing. Yeah, we got a functional piece of software. It works, it does the job, but it's not what the client was looking for. Is that going to be something that is going to succeed? No, that's not a successful DevOps approach, right? The successful approach is where we have clients. Clients can be anybody. It can be internal clients, so other departments in our company. It can be external clients. It can be any stakeholder in the business, any stakeholder in the application, anybody who has any kind of interest in the application. They can come along and say, okay, I'm an accountant. I have no idea about what DevOps is, but I want to use this application because it will solve my accounting needs. So let that accountant run it, work it, see what they come up with, and that is part of the testing. That has to be the part of the testing, because if the accountant says, yeah, this is a great piece of software, keep the good work up, then we're on the right track. And if they say, I don't think this is very usable, then of course we need to change our plan. The release cycle, once we got everything tested, very important to do frequent releases. Frequent releases, what they will help us with is having the application updated, having the application patched, secure, and of course modernizing it continuously. Now, in the release cycle, we got to be careful about how we do the releases, how fast we do the releases, whether the client can even keep up with the speed of the release. Are we doing automatic deployment, or is the deploying going to be manual? Of course, that will also be very dependent. And in the deploy cycle, we're going to deploy that application to a certain environment, a certain production environment. Then once we have it in the production environment, we need to monitor it. We need to monitor it from the point of view of performance. We need to get a baseline down, see what the application was doing before we got the new release in, see how it's performing now, whether we have an increase in latency, whether we have an increase in number of users, whether we have a decrease in the performance overall. We need to know those metrics, and we need to take care of understanding where to get those metrics, how to get those metrics, and what they mean. And of course, we feed those metrics back into the planning phase and then run that cycle again, right? So CI/CD is going to be our next chapter. So with CI part of CI/CD, CI/CD is continuous integration and of course continuous deployment or continuous delivery. We're going to look at the CD part. So CI/CD essentially is making the code and merging it into a repository that is shared, that has versioning in it, and of course that repository should have all the code committed as quickly as possible. We're talking about committing usually several times a day, making sure that when a piece of code is written, the developer saves it. When they save it, it should automatically go into the commit phase, right? So once it is committed, that can trigger automated build and testing, right? Automated build and testing is sort of part of continuous integration, continuous development, because what we want to do is we want to have feedback from each commit that each developer puts into the environment, right? So if there's a build failure on that piece of code that was committed, we want to get feedback as soon as possible, right? So we test early and we fail early, right? We test as soon as the code comes onto the repository, and then as soon as we get one error in that code, we fail the test and we reply back to the developer saying, this is where it failed. This is the line, piece of code, code snippet, whatever we're referencing. This is the problem that we have. Please fix that. The developer goes back, they fix it, they push another commit that automatically triggers a build and test. If the build and test succeeds, then they get a response within minutes. Yep, build succeeded, test succeeded, ready for integration testing, or whatever the next step is. It could also be automated integration testing, right? It could be just put in the queue for integration testing, and then the integration testing would run as nightlies or other types of tests. So this is really dependent on whether you are doing integration-based testing automatically or whether it is a manual step in there. So as we said, every commit should be built and tested, test incrementally. So test all the smaller changes, each of them separately, and fail fast. And of course, the results can either be delivered to the developer or to a dashboard, something like a public dashboard that all the developers can see, or maybe to a dashboard that is visible to some key stakeholders in the whole DevOps process. Continuous integration also requires us to clone the development infrastructure into the test infrastructure to make sure that our development infrastructure and our test infrastructure are completely equal, are the same versions, are the same types of servers, types of instances, types of containers, etc. And of course, that process further on leads into QA and staging and production, and that cloning essentially in CI/CD just replicates itself. Why do we want to clone the development to test? We want to make sure that when we are deploying a piece of code on the development and it works, it's going to work on test. It's not going to be dependent on some infrastructure changes, and those infrastructure changes break our piece of code, etc. So update frequency in continuous integration can be up to multiple releases per day, up to multiple builds, up to multiple tests, up to multiple integration tests, etc. Right? So this can be really a really good way for building any kind of software that is time dependent. Anything that needs to be built fast, anything that needs to be released to market really quickly. Think mobile. Right now, you have to do if there's a new mobile application and you want it to go viral, you have to have it ready and working properly within days, right? Maybe even within a day. Depends on the size of that application. Think about security, right? Any kind of security features where a breach or a vulnerability is found, right? How do you fix that security issue? Continuous integration is a great approach. Your developers can start building those security features, can start building those layers of security into your environment, and you can have multiple releases of that of those iterations of security features within a day, and then you can have a fix at the client environment within the 0-day time frame. So the CD part. So are we doing continuous delivery or are we doing continuous deployment? So continuous integration is always part of this, whereas continuous delivery will continuous delivery or continuous deployment will sort of depend on application ownership, right? So do we own the application? Can we do the changes? Can we approve releases into the deployment process? Or does the client need to do that? Does the end user need to do that? Does the end user have control? Is there sort of a manual step where somebody has to come in and overview whether these deployment packages are part of the are going to be approved? So continuous deployment the code through the build, through the integration testing, through the release cycle, down to the deployment. So between the release cycle and the deployment, what we would have is we would have some kind of automated approval process. That automated approval process can be additional functional testing, automated staging testing, deploying an environment that mirrors your production environment for maybe a few hours and running full-scale tests on that environment, right? So any kind of automatic testing that will ensure that each piece of code that is going to be committed is actually going to work on our environment. The second consideration is, do we want to have full automation? Do we want to change things in the application? Do we want to change features, add features, change user interfaces, etc., right? So that is a complex question that needs to be answered. Continuous delivery is much more suitable for any kind of environment that is complex, where those questions are difficult to answer, where those environments are difficult to test, where the integration itself with the production environment is going to be difficult to achieve or difficult to predict whether that's going to work. It's always going to be a matter of whether we're owning it or not, and how many deployments do we have? Is it something like a piece of software that is commonly used by end users around the world? We can't really force them to have the latest version. We can't really force continuous deployment on them. We should let them choose whether they want to update. We should notify them, here's an update. Do you want to update right now, right? And then they can say yes. And that can be sort of the approval for the continuous deployment process. But we cannot push continuous deployment on something like, for instance, corporate environment that requires where the governance or where the compliance requires verification of that application in a staging environment that needs to be verified against the questionnaire, like PCI DSS or something like that. That continuous deployment is very difficult to achieve there. Continuous deployment, however, is very easy to achieve if it's an application that we're running on the web that gives our users a web console, which always remain the same. Remember, continuous deployment, if you're changing the graphical user interface, then you're going to have problems, right? Try to keep the application looking the same, but giving it more features, making it faster, making it respond quicker. It's about trying to fix those little issues with the microservices. They're not responding fast enough. They have a bit of a latency. Let's try to fix that latency. And continuous deployment is really good in that kind of sense. Right, so continuous delivery essentially is a practice of automating the build, test, and release cycle, right? So essentially, it ties into what the CI part of the environment does. So the continuous integration already does the building and the testing, and the continuous delivery is sort of an extension which automates the release of the software, right? So it makes the released software available on a repository, and by making it available on a repository, it allows our users to pull that software and install new versions. We can also have triggers in the CD process that will notify users, here's the new version, download the new version now, etc. Right? We recommend you download a new version, or urgent security update, etc. Right? What the continuous delivery does is it allows a manual intervention, manual verification, installing to staging before we install into the deployment, verifying the install on the staging separately of the DevOps team, etc. Right? So the update frequency in continuous delivery is very much dependent on the actual production team that is doing the deployments. We're talking about usually days to weeks. Are going to be the shortest update frequencies, right? So in some aspects, continuous delivery breaks the goal of DevOps, breaks the sort of purpose of DevOps, having fast releases, agility, quick updates to our application, etc. Right? But it is a necessary evil in a lot of corporate environments. So don't feel bad if you can't go for continuous deployment. Continuous delivery is as good because it can ensure that the application is delivered much, much faster than traditional waterfall approaches or other development methodologies. Continuous deployment, however, it's about delivering the software and, of course, deploying the application updates automatically, right? So it's an extension to continuous deployment, which essentially automates the delivery of software by having automated checks, by having an automated release to a staging environment that probably mirrors the production environment, by having rigorous testing done on the staging environment, by trying to break the staging environment, see the load testing, use software like bees with machine guns that can attack your application and try to destroy it and see if that application survives, right? So essentially, the continuous deployment requires us to have stringent processes that will actually verify that the application will survive any kind of eventuality inside of the development process. So once it's released, the software is automatically verified and then deployed to production. With continuous deployment, we also have the ability to do multiple deployments per day, right? So continuous integration, continuous deployment is where it's at, right? If we want to be a sort of on top of the application all the time, at any minute say, yeah, we need to change this functionality within the next hour. We need to patch this security hole within the next hour. Then continuous integration, continuous deployment is where it's at. However, continuous deployment is not easy to implement. Not easy to implement. There can be multiple hurdles when talking about implementing continuous deployment. Right. Now let's look at infrastructure as code. So how do we manage our infrastructure so that it is automated, so that it is deployed very, very efficiently? Infrastructure as code essentially is making sure that we can deploy and maintain our infrastructure completely through automation scripts, right? So that we don't need to have any manual intervention, so we can stop thinking about servers, we can stop thinking about boxes, and start thinking about services. The infrastructure as code, of course, requires us to already have a highly automated environment, already have an environment that is addressable through programmable approaches, command line interfaces, API calls, certain management servers, GUIs, etc. So that environment sort of has to be deployed somehow, or we have to use an environment like the cloud, right? Infrastructure as code usually will have industry standard orchestration tools supported. So we should be looking at whatever is an industry standard. So there are some orchestration standards out there that tell us how a piece of code should be written to provide certain functionality. An open source standard is Tosca. So Tosca is the topology, orchestration, and system something standard. So Tosca defines the way we need to build our templates so that they are sort of compatible with other components, with other industry standard tools. And so that these industry standard tools can communicate with each other and use each other's scripts, or maybe integrate scripts from one service into another service, where service A calls up service B with its own orchestration tools. So you also have cloud environment dependent tools that are cloud environments that will have their own tools. So each vendor has built their own orchestration tool, and most of these orchestration tools are also Tosca compliant, so that they can integrate with the industry standard orchestration tools. So infrastructure as code essentially is making sure that we can store our infrastructure specification into a document, and then put that specification document into a software repository. And in that software repository, we can specify this piece of infrastructure needs to be built for this software to work. So we treat it the same way as we treat our code, and we can deploy it alongside our code. We can deploy it into our CI/CD process and take the infrastructure as code document, push the infrastructure as code document into the cloud environment, then deploy the cloud environment will then deploy the networks, the machines, the containers, the storage backends, the object storage databases, whatnot, right? Anything that is supported in the cloud will be supported through infrastructure as code orchestration. And once we have that, we easily deploy our software onto the infrastructure components and manage our software with our CI server, with our CD deployment tools, with any kind of tool that we want to use. So traditional approach to building an environment is, first, what we need to do is we need to spec and source our hardware. That is days or even weeks to get it done. Once we got it, we deliver and install it into a traditional data center. We make sure the cables are nice and organized, just like in the picture on the right. We connect it to our network, we connect it to our SAN, we connect it to power. Again, this we're talking about hours, possibly days. We install an operating system, we install the software, we test on a small scale. And once this test has gone through, this is ready for production. Time scale for time to market for a traditional approach of building applications is days to weeks, right? So maybe we can get it done in days, but usually it's going to take weeks, possibly even months for our application to be deployed. Is that going to work with modern applications? Is that going to work with applications that quote unquote go viral? Probably not. Nobody's going to wait for 2 months for us to release a new version of our online game or a new version of our time management software or a new version of our chat tool, right? So the point of the traditional approach is it's slow. Yeah, it's very reliable and it's been done for a long time, but it can be slow, it can be expensive, and it will stall our time to market substantially. Infrastructure as code, essentially, it's write your specification document, store that document on a repository. Once it's stored on a repository, it's ready to deploy, right? So writing the specification document maybe takes us 10, 20 minutes, maybe an hour or two, if it's a complicated one, right? To store it on the repository, it's under a second. Whoops, sorry, wrong button. Then we tested production scale. So what we have with infrastructure as code, and when we're using the cloud, we can deploy an environment that is the same size as our production environment. Does our production environment have 100 servers? Build a test on 100 servers. How much is that going to cost you? Your for 3 hours, right? It's going to be insignificant to the cost of the whole application. If you test it for 3 days, it comes to less than 1% of the cost of your whole application, right? Think about what you can do in 3 days for the cost of less than 1% of your running application. That is an amazing power that you can never achieve with a traditional approach. You can never achieve that with your own environment inside of your own data center. Are you going to have the same amount of hardware ready to test all the software as you have for your production environment? I don't think so. Maybe 20%. Maybe that's like the largest scale that I've ever seen in any traditional environment. In the cloud, it's if you put 20% of the money of your application that you're running, you can test at full scale for over 2 months. Over 2 months of running of full scale testing every year for that 20% of the cost that you would usually spend in a traditional data center. So testing at production scale is something that is basically the best feature of cloud for me, in my opinion. From a repository where somebody's already written it, run at production scale, test your software on a production scale, takes a few minutes to hours, and then deploy to the production. So what's our time to market? Minutes to hours. We can say, okay, we want a new version of our application. We want to do these changes. We send the changes down to the development team. The development team comes in 45 minutes later with a solution. We push it into the test. We test it at production scale. We see it doesn't work. We push it back 45 minutes later. We've got a new version. We push it. We test it at production scale. We see it works. We decide, let's push to production. Within 2 hours, we have a new version. We have the feature. We have the security. That's the speed of cloud. That's the speed of the DevOps process that we want to look at. And infrastructure as code is a crucial part of that approach. So the benefits, obviously decreasing time to market, right? That's the biggest benefit of infrastructure as code. Increased automation, making sure that we can automate all parts of infrastructure management. So infrastructure as code usually will have the ability to version that code that we're doing. So when we're versioning it, we can compare what changes are coming in. We can try those changes again on another environment at production scale in an automated fashion. And of course, that will allow us to completely automate the testing process. It will also allow the increase in reliability because we know what's going to happen when we deploy it. We know how it's going to operate once we deploy it. We know the performance metrics. We already can get a baseline off of the test environment because it's already at production scale. So pick up a baseline off of that one. Don't even bother picking up a baseline from your current production environment, right? And of course, it's all about repeatability because we want to clone our test into our, in development, into our test, into our QA, into our staging, and then into our production. So that's 5 environments that you should all be running, and you're already running probably, or, well, you will be after this presentation, I guess. All right, we're at about the half point of our presentation, so we're going to take a 5-minute break. If there are any questions, if there's anything you want to ask about DevOps, about development, about SysOps, about infrastructure as code, now is a great time. Just type your questions into the Q&A section, and I will answer them after the break. All right, so we're back. There were a few questions in this section. So, top developer tools by Mohammed Sek. There are too many development tools that we could count. So we have different tools that cover different aspects of DevOps. So everything from continuous integration to monitoring to tools that you build, that do releases, that can create packages, that can transform packages from one format to another, to package repository tools. So huge amount of different tools. We will, however, look at AWS tools that align with the development and DevOps processes. Next question by Mohammed. Can DevOps work with ITIL environment? Yes, it can fit perfectly with ITIL. It can really help us achieve the high standards that are outlined by ITIL, because we can work progressively on getting to that standard, right? We don't need to go straight through that standard from out of the box, whatever we have, right? We can progressively and incrementally sort of try to meet the ITIL standards, or we can, try to build up applications with ITIL standards in mind and say, this is what we need to adhere to. An ITIL standard can be considered something that's a requirement in the backlog of our application, right? Also, DevOps can really help adhere to the SLA, can really help even beat the SLA objectives, because we have quick response and quick turnaround times, right? So if we see that there's a critical issue with our application that's going to, mess up our SLA, we're not going to meet the SLA, we can just push that into the DevOps cycle and really work on it and fix it. There was also a question in chat from Rajastri saying, I will be moving from a SysOps to a DevOps role. What would be the specifics that I would need? So essentially, you have to know about your future role a bit more to be able to answer that question. So general recommendations is things like, if you're a SysOps engineer and you want to move into a DevOps role, pick up some scripting languages, simple JSON or YAML, or maybe even Python, right? Python is really good because in Python, you can do both operating system scripting and actual real hardcore programming, right? So Python is really good. It's open source, right? If your company doesn't do Python, then, maybe get some Java basics. Familiarize with yourself with how code is developed, what the processes, what commit, build, release phases are. And of course, if you know what tools you will be using in the future, then of course that will be critical. There we go. Slides are shared. Sorry about that. I guess we lost the share for some reason. Okay, there's one more question in the Q&A from Fernando. What are the top skills required to become a good DevOps person? Ooh, what do we have to do that? So DevOps people, well, basically it's communication skills. Basically, it's trying to being able to understand all these concepts from these different fields of IT, right? So what we've been doing for the past 20 years is segmenting IT into specialized sort of knowledge areas, right? We got the developers, we got the SysOps team, we got the networking team, we got the SAN guys, we got the server guys, we got the virtualization guys, the integration guys, right? If you want to be a good DevOps person, you sort of need to start to tie those together, right? You sort of need to understand how developing a piece of code will affect the running infrastructure and how the running infrastructure can support that running piece of code. So it is being able to be good at everything. That's a good DevOps person. And one more thing about DevOps, you have to sort of be able to understand how to get to from a certain business idea to a certain technical concept, right? So being a translator of business idea into technical concepts. That's a good DevOps person. Okay, typical team structure, a question from Joe. What is the typical team structure? Essentially, you have to have at least, so at minimum, I would say 3-4 people. That's the minimal team structure for a DevOps team. You have to have one person with really good technical skills on the development side. You have to have one person with really good skills on the SysOps side. The rest can be a mix and match. And then you have to have somebody who will be the team lead, right? So you have to have one guy, one girl, one person that will be taking over the management of the team. It's not going to be easy. It's, you know, it is a task, right? Okay. That is all the questions for now. If you still have any more questions, please stay away from chat. My chat window is closed, so I only pick up those questions very, very late. But make sure you write into the Q&A if you have the questions. All right, let's continue on with our presentation. So what are the challenges solved by DevOps? What can we do with DevOps, right? So the benefits of DevOps essentially is to increase the velocity of the development cycle, to make sure that we have a very fast development cycle that will be able to introduce small little incremental changes, but the changes that will matter, right? We want to get the most important tickets resolved as fast as possible. That is what the benefit of DevOps is. That will lead to a decreased time to market. And of course, that can also enable the business to pivot, right? For a business to pivot, what it needs to do is it needs to have the new generation of requests, the new generation of what we need to do, and have an old application. And then sometimes in a traditional approach, you have a waterfall approach, you're building the application, you cannot pivot. You have to go through the waterfall to build that application. With DevOps, what you do is you look at the existing tasks, you say, okay, 50% of these tasks do not matter. You drop those tickets, right? You fill the backlog with the other tickets that matter, and you pivot, and you change what you're doing, and you change the way you're doing things. You fix your application so that it is relevant to the user. You make that application usable by the user as fast as possible. That also inherently increases application flexibility, right? With the DevOps process, you can change the application in a matter of hours completely, right? You can change the functionality, you can change what it does, you can change how it does things in a very, very, very short time. Of course, you can also increase the reliability of the application through DevOps because you automate, right? The automation will increase the reliability of the application itself, of the deployment process, of the installation process. It will increase the reliability because you're moving from a verified environment to another verified environment, to an even more verified environment, to even more verified environment, to production, right? So testing, which is already verified, to a release which is more verified because it's gone through testing, to staging, which does additional testing, so it's even more verified, and then to production, right? And of course, the biggest benefit of DevOps is the ability to experiment, right? That is something that you need to have. Whenever you have a DevOps team, if you're a manager of IT people, give them 20% of the time and tell them, do whatever you want. Have a passion project, experiment, right? That's what these leading tech companies do. All leading tech companies have passion project initiatives. You have to have a passion project. You have to have something you believe in. You have to have something you care about, because that makes you more productive. That makes you much, much more efficient in your day-to-day work. And of course, anything that they build out of that experimentation, you can drop into that application, make the application better. The ability to experiment, the ability to use the cloud and use the services in the cloud to experiment for free or very cheaply is the ability to innovate at a much higher pace. And who's the winner right now in the tech sector? It's the companies that innovate, right? Yeah, of course, you have to be there at the right time when the application is going to be used, right? So you could either be too early to the market or too late to the market. If you're too late, you're not using DevOps. If you're too early, you're a visionary, right? So if you were too early to the market and your application failed, you're a visionary. If somebody else came along, if you were the one that invented Twitter in 1999, you're a visionary, right? that's nothing to be ashamed about, right? You were too early, you had the idea first, and it happens. But if you're trying to build a new Twitter now, you're not using DevOps, right? You're too late because it's already been built. So use cases for DevOps, any kind of environment that has very dynamic requirements from the end users, from the clients, where a lot of changes are coming in. That's very, very good for DevOps, right? So when the clients are saying, okay, we're using this application, we want to have this feature, we want to have that feature, and they're submitting tickets on a daily, weekly basis. That's where DevOps comes into play, right? That's a good use case. So sort of client-driven development. So the client says, we want to have this, and you build it, right? Rolling releases, where we want to have an automated environment that is continuously updated and the releases continuously roll through that environment, right? There are applications out there, huge applications, web scale applications, enterprise applications that have a continuous integration, continuous deployment methodology built into them, where they go through 10 iterations of a piece of software a day, right? So 10 releases, 10 rolling releases a day. So that's the kind of environment that's good for DevOps. Security responses, responding to vulnerabilities, responding to any kind of issues, even your response teams should be using a DevOps approach to fixing any kind of issue, right? A DevOps approach doesn't necessarily need to be tied to development. That's something nobody thinks about, right? DevOps is about ways of doing things. It's about the methodology. It's about the human behavior when we're doing DevOps things. You can implement a DevOps approach into your security response team. And your security response team, they get a ticket. They treat that ticket as if it is input into a code environment, right? The security response team, all they need to do is maybe change some automation scripts to respond to that security breach or attack or whatever. DDoS attacks are really good. So for instance, suddenly you see a DDoS attack from a certain set of IP addresses. Well, what do you need to do? Well, you need to change your firewall rules. Those firewall rules can be a specification document that gets pushed up to the firewall. Store that specification document into your repository, quickly run it through the test to see whether it's written correctly, and then apply to production. DevOps approach, nothing to do with development, everything to do with response to security issues. This is why DevOps is so usable. It's not just for development. Automated software update systems. So anywhere where you have a client application that updates itself, right? So something that essentially is running on a certain integrated device or on a certain operating system or some kind of service, right? And that application can then automatically be updated. So very, very known use case, Tesla cars, right? Tesla cars, they have an automated software update system, all the Tesla cars in the network. It's continuous integration, continuous deployment, right? So you wouldn't think, oh, a car manufacturer using DevOps? Yeah, that's what they're doing. One really good example with Tesla was last year when they had this issue where Consumer Report was testing their braking and they found inconsistencies in the braking of the Model 3. What Tesla did is they took that input into a ticket, did the testing of the physical vehicle, wrote the software that changed the performance and the operational characteristics of the car, sent that update to all Tesla cars within, I think it was weeks, and all the cars are safe now, right? So that is an automated software update system on a real world example that uses something you wouldn't completely usually associate with DevOps, right? Hybrid cloud and disaster recovery. So when you have your on-premises and your cloud environment, and you're trying to make sure that you can move your applications from on-premises to cloud, that you can distribute the load between on-premises and cloud, this is where DevOps really comes into play also. It focuses on the systems operation, right? But because you do scripted deployments, automation in the actual infrastructure deployment, you're using infrastructure as code, you can put that infrastructure as code into a standard DevOps process, right? And automatically build that infrastructure in the cloud and even integrate both cloud and on-premises. What about the drawbacks of DevOps? It's not all great, is it? It can be challenging. It requires a change of the corporate mindset, right? A lot of the times there will be a lot of talk about, you know, oh, we're doing DevOps, but the corporate mindset will be still, okay, when we build the application, we build it on these types of servers, we give them this type of CPU, this much of memory, and then we push it to the verification team, and that's it from our side. Is that DevOps? No. The corporate mindset needs to change to sort of give application ownership to the team, right? Do you need to put it through verification? Do you need to put it through compliance testing? Do you need to keep governance on that application by a certain special team? If you do, get a team member from that team, assign them to the application so that they have the security part of the ownership, or maybe even two people, so that they have the compliance part of the application, the ownership of that application, right? You build it, you run it, you secure it, you make it compliant, and you put it into production, and then you decommission it. That's what the DevOps team should be doing. When a company says we're doing DevOps, but they're passing around an application and passing around the ownership of that application, then that's not DevOps. You might be using DevOps tools. You might be using Jenkins as your CI server, but you're not doing DevOps because your team is not owning that application from end to end. DevOps also needs to align with the global strategy of the company, right? So there are ways of aligning DevOps to corporate strategies, and there are corporate strategies that are completely incompatible with DevOps. So that is going to be one of the questions, whether you can even introduce DevOps into your global strategy. So really, these two are, you know, C-level business decisions. These are not decisions for DevOps engineers. These are not decisions for SysOps people. These are not decisions taken by the developers. These are C-level decisions. This is something that needs to become a strategy. This is something that needs to be aligned with the global marketing strategy, with the global development strategy, with the global production strategy, whatever kind of strategy your business has. And those things need to come from the top, from the highest levels, right? There's huge amounts of training for DevOps tools, for DevOps features, how to implement DevOps, how to migrate from waterfall to DevOps, how to be agile. There's not a lot of training on C-level DevOps, and that's something that we are trying to introduce also. A lot of training that will be, this is what you need to think about. This is how you need to change your corporate mindset for your DevOps to be successful. Number of tools, huge. What do? They all do the same thing. There's continuous integration tools. There's monitoring tools. There's tools that will store your code. There's different types of repositories. So which repository are you currently working with? Is it DevOps compatible? Can you take the code from that repository and trigger automated installs, right? So in the whole myriad of different tools, just Google DevOps tools and you'll see there's going to be a huge amount of tools, right? Which tools are you going to use? Are they going to be effective? Is it going to be driven by the developers? Is it going to be driven by the business side? Is it going to be driven by how much those tools are costing us? That is the question. One big issue in DevOps can be developer fatigue. So developer fatigue is essentially working on issues that are largely the same over and over and over and over again, right? Fixing the same issue, getting into constant pushing, battling with timelines. Try to figure out a way to minimize the developer fatigue. Try to give them a lot of time off, right? Tell your developers, you're a crucial part of our company. You need a vacation, take a vacation. Pay them, give them paid vacations. That is one of the best ways you can mitigate developer fatigue. Unlimited vacations are not uncommon anymore around the industry. And you see that most of those unlimited vacation policies come from companies that have introduced DevOps. Unlimited vacation doesn't mean that somebody will be out of the office for 6 months a year. No, people want to get back. People want to get back to what they like doing. Also, have them choose what they're going to be doing. Not everybody is good at front end. Not everybody is good at UI. Not everybody is good at developing APIs. Not everybody is good at integrating with hardware, integrating with virtual machines, integrating with operating systems. So developer fatigue mitigated with having the teams self-organize, having them choose their own tasks. If some bunch of tasks of a certain type are left behind, then you need to hire more people who will be glad to do those tasks. Don't push them onto people who don't want to do them. And of course, give them a passion project, right? Have time dedicated to passion projects and tell them, look, this is your passion project, experiment, do it. That's also going to reduce developer fatigue quite substantially. On the other side, user fatigue. Too many user side changes, too many new features, users being overwhelmed by constant UI changes, right? Don't change the user interface if you are if you have users that don't like that, right? If users are not requesting the user interface change, don't change it. Leave the user interface as it is. Add features to the menus, add features that can be selected from the user interface, but don't change the graphic outline just because you think, oh, this looks better. Have the users delegate that task to you. Have the users say, yeah, we don't really like the user interface. We would rather have this sitting on top left corner, etc., right? So user fatigue can also be a very, very big problem. And of course, that's the only way to mitigate that is to listen to the users. So benefits of cloud for DevOps. So how do we use cloud to make sure that we get the most out of DevOps? So the first thing about cloud is it gives us increased agility, right? So cloud offers us all of these different technologies. It offers us everything from physical servers to virtual machines to containers to serverless processing units. And we can mix and match these together. We can choose the right solution for the right approach. And for instance, with containers, what we can do is we can build a container on one cloud environment and then take that container and drop it into another cloud environment, drop it onto the laptop, drop it onto anywhere, and it will run, right? So we have huge agility when choosing what kind of system we want to run on. We have the ability to increase the size of that system, to scale that system in and out, to dynamically provision resources straight from our code. That is sort of benefit number one straight out of the cloud. Benefit number two, there's built-in tools, right? So for each cloud provider, there's a bunch of tools that are designed to help you build CI/CD environments and run CI/CD cycles straight in the cloud. We're going to look at AWS tools today after just a few slides that we have here. And we're going to look at what each AWS tool that we have does and how it aligns with the CI/CD and DevOps processes. You also have global reach. So most prominent cloud providers nowadays have data centers across all continents. They have locations that can run software. They have locations that do caching. They have locations that can store data around the globe. And if you do have an application that is web scale, that is global, you can position that application in the right region at the right time to get the closest response to the user, to be compliant with regulations also. So for instance, North America has different regulations than the EU, which has different regulations than Asia, that has different regulations than Australia, etc. Right? So if you are working in all of these geographical areas, you will of course have to sort of keep the data that the user is storing, especially if it's personal information, keep it in that region, right? That's why, for instance, AWS has data centers in North America, Canada, the US. It's got a data center in South America, in Sao Paulo. It's got data centers across the EU. Now that Brexit is happening, also data centers in London and data centers in other parts of the EU, so that the UK can easily move out of the EU and have that we can still be compliant with their local laws afterwards, because there's going to be a London data center outside of the EU, straight in the UK itself. We've got data centers in China, data centers in India, data centers in Australia, Singapore, Hong Kong. So essentially, it is close to most urban populated regions. And then there's edge locations, which are even further distributed out and closer to other regional areas. And of course, one of the biggest benefits probably of cloud is the ability to go serverless, to use the technologies that are in the cloud, to use the platform services that allow us to run the application without ramming to run servers. No more servers, no more operating system, no more patching, no more management. Write your code, drop your code onto function processing environments, build your front end on API environments, build your code and store it in the service that's there for storing the code. Also, know your provider. Make sure you understand the features. Make sure you know what the provider provides, and architect your solution according to the best practices. Each provider, each vendor will have their own best practices document, and they will have tools to look at your environment and see if you have built your environment with best practices. So in AWS, we've got Trusted Advisor. Trusted Advisor can check our environment and see whether we've built in to best practices. Always design for failure. Make sure you build your application and then try to destroy it, right? Try to destroy it, see how it reacts to failures, how it reacts to missing containers, missing virtual machines, and learn from that. Also, play frequent game days, right? That's one thing that will also do a dual job, right? It will make sure that the work is fun so that the developers don't get so fatigued. On the other hand, it will give you scenarios where you test your application against attacks, right? So what we do in game days usually is we set up a couple of teams and they compete against each other. Team A competes against Team B. Team A tries to destroy the application, and Team B will continuously monitor and try to mitigate that attack, right? So we have points for instance, reaching a certain level of security, breaching a certain firewall. We have points for gaining access. We have points for DOSing the environment. So there is that is a real requirement nowadays, so that we can learn how our application operates, how to protect our application, and what the weaknesses in our application are. And then we can take what we've learned in the game day and feed it back into the DevOps process and quickly build and iterate that software to mitigate all the issues that we've created. Right, so now on to AWS tools. So the first developer tool is Cloud9. So Cloud9 essentially is a cloud-based browser integrated environment. So what we do is we write code in the browser. We can run that code in the browser. We get a command line straight into AWS. And of course, it is an all-in-one code editor, debugger, and terminal, right? After we've done our development, we just push that code in production through the Cloud9 environment. We run standard Git commands to push it into the repository, and then from the repository, it can go through automated testing, and we can see how that's done. It has integrated collaboration tools, so you can connect to one file, one piece of code, and have multiple different developers work on it. With collaboration, you can do things like have different colored markings to who's working on what. People can type into different sections at the same time. You can have annotations from different people when you're doing reviews, when you're doing commits and things like that. And it has seamless integration with serverless components. In AWS, it's integrated automatically with Lambda, with API Gateway, and other serverless components, and lets us build those serverless components straight out of the browser. So no install necessary, no prerequisites, nothing. We just open up the browser, we go to the Cloud9 section, we create a Cloud9 environment, and then we start coding. So it's minutes to start coding. You can also run the code on AWS environment, on EC2 instances, or on an on-premises server that has SSH accessible over a public IP address. Next, we got CodeCommit. So CodeCommit essentially is a source control service. It's a repository that is completely standard Git-based. It uses standard Git commands to upload to the environment. It is secure because it automatically encrypts everything, and it is highly available. It automatically scales. It can store unlimited amounts of code, right? Unlimited sizes, unlimited amounts. You can store artifacts with your code. You can store whatever you want with your code. And it has a free tier for up to 5 developers and up to 50 gigabytes of data. Whereas on top of that, it's $1 per developer, and each developer gets an additional 10 gigabytes extension. So essentially, it has unlimited capacities. You can have as many people working on it as you want, and it's very, very, very cost efficient. No and builds the source code. It can also do integrated testing. The integrated testing essentially allows us to automate the testing features. It's automatically encrypted, so everything that's done is automatically encrypted. The CodeBuild environment scales the number of build units according to the number of requests, so it's completely dynamic, and we only pay for the machines that are running the builds. It is extensible with external build tools, so CodeBuild can integrate with Ant or Maven or other features that you want to build your code with, right? So it completely integrates with CI servers like Jenkins, etc. So it is really cool, or you can use the built-in AWS tools to build your code. Essentially, what CodeBuild does, it spins up EC2 instances that will actually perform the build. Those EC2 instances go to the repository. That can be CodeCommit. That can be any Git repository. They will pull the code that CodeBuild would instruct them to do. They will build the artifacts, and then they will store those artifacts onto an S3 bucket or another different repository that we're using. After we've got the code build, we can use CodeDeploy. This is another serverless environment that automates the software deployments. So essentially, it's a centralized control environment where we can deploy software to different fleets of servers, different fleets of containers, different environments that we can control, that we have access to. So automatically tracks application versions that were deployed. So we have the ability to roll back the application really quickly, and includes health checks that can be integrated at each stage. So we can integrate a health check before we deploy, during the deploy, and of course after the deploy is finished, final health check to see whether the application is running. If it's not running, that health check fails, and CodeDeploy can roll back, pull the older versions from the repository and perform that. It can also do rolling deployments, doing things like install one by one. So install the first server, health check. If it works, install the next one, and then next one, extend next one. Or maybe half and half, do half of the servers, install them, and then after it's done verification, do the other half, right? So it will always allow for our application to be highly available throughout the deployment process. So those were the developer tools, right? So the developers, essentially from a CI perspective, they will commit the code, they will write the code, commit the code, they will build the code, the artifacts, and sometimes, as we said, they will also install, and that's CodeDeploy there. For DevOps tools, we've got CodePipeline. Now, CodePipeline is a continuous delivery service that can automate the complete process of how these tools are being used. So we can use Cloud9 to write the code, and once it's pushed to CodeCommit, that can trigger a Cloud pipeline, and the Code pipeline can automatically run any release pipeline, right? So it can go from CodeCommit to CodeBuild, and that will build the instances, then to CodeDeploy, and that will deploy the staging. And after the staging is verified, it can go again to CodeDeploy and deploy to production. So it is designed for rapid delivery of software. It is designed for continuous delivery, not continuous delivery. And of course, it can be integrated for continuous deployment. It's an easy model to, it's really easy to model the release. It's just a graphical interface. You just drop in the components and drag and drop, so anybody really can do it. And it integrates with any AWS and other CI/CD tools like, you know, build tools and Jenkins and other tools that are out there. CodeStar, it's an even more integrated component. It will manage the complete life cycle in one place. So it is a graphical user interface that's really easy to use and very intuitive. You can just drag and drop all the components. You can build pipelines. You can build users. You can build the collaboration on the projects that they're building on. You can upload files. And it's really, really easy to get started. You have pre-designed templates, and you just pull a template. You're building a web application, you're building microservices. You pull a template, you drop it in, you invite other people, and once they're in, everybody can start coding. So essentially, you know, you can get started really, really quickly. Even if you're new to DevOps, CodeStar has everything built for you. Next DevOps tool is CloudFormation. So CloudFormation is the orchestration service for AWS. It is the perfect solution for infrastructure as code. It is designed as an infrastructure as code service. So essentially what it does is you have templates that are created in JSON or YAML, and then you store those templates onto S3, or well, it stores the templates onto S3 for you, or you can store them onto S3 and then just reference the S3 file directly. Once it has that template inside of the environment, you can see what kind of infrastructure it will build, and once you start to deploy, it can deploy to your production. You can also use change sets. Change sets are a built-in versioning tool with CloudFormation. So if you make any changes, you can just make them through the through the management a console of CloudFormation. You can create a new change set and start writing the changes, and then you can compare those changes, see what changes, how the changes will affect the running environment, and once you're happy with that, you click apply, and it will go back and again change your running environment. It also integrates with the code tools, so you can use, for instance, for CodeDeploy, you can use a CloudFormation template to deploy the infrastructure, and then on top of that infrastructure, automatically deploy the CodeDeploy, the software that is being deployed by CodeDeploy. You can also integrate with other tools like Jenkins, and Jenkins can use CloudFormation to build the environment on which it does its own development. Another very important part of DevOps that is often forgotten is CloudWatch. It's a monitoring and management service, right? It allows you to collect metrics and logs from your environment. So it can collect metrics for your AWS environment, any instances, any storage, any networks, anything running as an item, an artifact in AWS will be reporting to CloudWatch automatically, and you can add your own custom logs, you can own custom metrics, you can pull metrics from your application, you can collect any kind of metrics that matter to your environment. You can also create alarms and actions on top of metrics. So you can do things like set thresholds for certain metrics, and those thresholds will trigger an alarm, and that alarm will push out an action. So it can talk to an auto-scaling service, it can talk to messaging service to send notifications, it can talk to a Lambda that will do intelligent actions on top of the environment, right? And integrates with other AWS services so that you can perform any kind of action on top of those alarms. You can also build dashboards. Dashboards will give you the ability to overview the metrics that matter to your application, right? So it will give you the information about how many integrations you had, what your the number of commits, the number of errors in the deployments, in the builds, the number of errors in the integration testing, and you can get your DevOps metrics, the metrics that matter to your application, and the metrics that will make sense to your application. Right, so we're coming to the end of this presentation. I hope you found that information that we just shared with you useful, and we would like to invite you to our upcoming classes. So we've got the TP2771, that's the AWS DevOps Certification Bootcamp. So that's for your professional DevOps certification. That will be running soon. I don't have the exact dates, but you can look on the website, webhsolutions.com/courses/AWS-training. We also have a new course that was just released today. It's WA2822. It's machine learning on AWS. So take a look at that course. Very, very cool course. Very, very interesting courseware. Again, if you are interested in any training, webhsolutions.com/courses/AWS-training. Look at that website. It's got very, very interesting stuff on it. This is the end. So any questions anybody would like to ask? I'm going to keep this line open for a few more minutes. So please enter your questions into the Q&A section. And yeah. So I'll give you a minute or two to gather your thoughts and ask the questions, and I can answer the answers, and then we can finish this presentation. All right, so we have a question from Mike. Will the presentation be available for review? Yes, the presentation is available for you to download from this website right here. I am pasting it into the chat. There we go. Slides for you to download. webhsolution.com/webinars/content/DevOps on AWS/DevOps on AWS.pdf. And that will give you the presentation. So I can also paste that right here. Just give it a little bit of a color. All right, so it's on screen also to download these slides. If you don't want to look into the chat, it's on screen. This will also be visible in the recording. Okay. Any thoughts on Concourse versus Jenkins? Both very nice tools. So Concourse, very useful if you are on Cloud Foundry. It integrates really, really, really well. Jenkins, more sort of open platform tool, right? And really, it totally depends on your preference. I like the Concourse's graphical interface. It's very sleek. That's what I can say about that. But other than that, I mean, I have my personal opinions, which I can share with you over a beer, not on a public platform like this one. Okay. If there are any other questions, please type them into the Q&A section. And if no questions, if there are no more questions, I will thank you for attending this training. It's been my pleasure providing this content to you. I hope you found this interesting. And here is our information. So if you want to, let me just do this. If you want to talk to us, call us. We have the numbers here for the US and Canada. We got contact information where we're located. So you're welcome, Lori. You're welcome, Lori. So yeah, if you have anything you want to ask, we're here. So yeah, all of our trainers are in both countries and we travel around all the time. So if you have anything you want to ask, we're available also for consulting. A little bit about our trainers. So most of us, we all have industry experience from the past. Well, myself, I've been in the IT for about 20 years. So we have industry experience from wide-ranging set of products, and we have hands-on experience, meaning a lot of us have worked with and still do work with these technologies. We're not just theoretical people. So we consult every day. We work with these things hands-on all the time. And I think that we have quite a nice group of trainers here. That's just my personal opinion. And we also have a very, very wide-ranging set of outside contacts that we can source upon if we don't have the knowledge in-house. But yeah, most of us, we have a wide-ranging industry experience from a bunch of different areas, if that says anything about us. All right. Again, thank you for attending. I will leave this session open for another 5 minutes. If anybody has any questions, I'm happy to answer them. If there's no more questions about at about 2:50 p.m. Eastern time, then I will close this session down and we will end this little webinar that we have going on here. So thank you for attending, and I hope you found the content interesting. All right, since there are no more questions, I'm going to end this session. So thank you again very much for attending, and I hope to see you on another future training or future webinar or the seminar that's going on in Toronto on April 4th. Goodbye.